Alright, in this video we are going to go over the functions of the CPU, registers and buses, and the fetch, decode, and execute cycle. Okay, to start off, let's talk about the parts of the CPU and their basic function. Up first we have the control unit or CU. Now the control unit is pretty much like the boss of the CPU. In other words, it's kind of like the CEO of a company, the CPU being the company of course. That's why I have an image of a guy in a suit right over here. Now the ALU right over here is responsible for math or basic arithmetic, logic, so like and, or not, and input and output operations. Note however that it only calculates and it does not store the result. Now let's talk about registers. So registers are basically very small storage locations throughout the CPU. Now the first one we have over here is the accumulator, which stores results the ALU produces. Think of it as a notepad where the CPU stores the results temporarily before deciding what to do with the results. Now the program counter basically contains the address of the next instruction that is going to be executed. Think of it as an arrow always pointing to the next instruction. Then we have the instruction register, which holds the instructions that are being executed by the CPU. Think of the IR like a clipboard or notepad which the CPU needs to place the current instruction on. Next we have the MAR or memory address register, which holds the addresses of the memory location which the CPU needs to access. And our final register is the MDR or memory data register. Now the MDR holds the data collected from the main memory for a very short period of time. It gives the data to the IR, which then the CPU can access. It can also be used to hold writing data. Now how are these different parts connected? Well, they're connected through buses. There are three main types of buses. The address bus is the connection between the MAR and the main memory. This bus carries the address from the MAR to the main memory, and it's unidirectional because it only goes from the MAR to the memory. Next we have the data bus, which is the connection between the MDR and the main memory. This connection allows the transfer of data held by the main memory to the MDR. This is bidirectional because it can only go from the main memory to the MDR or the MDR to the main memory. And then we have the control bus, which basically manages the timing of what is going on in the CPU so everything happens or occurs at the right time. Okay, so we know the function of each piece of the CPU, but how do they work together? How do they function together in order to complete a task? That's where the fetch, decode, and execute cycle come in. So the fetch cycle is basically the process of getting the instructions from the memory. We know that the memory has data and addresses corresponding to that data. And so the fetch cycle is pretty much getting that data. Now it all starts with the CU. The CU, being the boss, tells the program counter, which always points to the next instruction, what is the next address. The program counter says, for example, the next address is 1001. So the CU then tells the MAR to basically find the address 1001 in the memory. Now, the only way the MAR can communicate with the main memory is through the address bus. Next, the CU basically tells the MDR to read the address and grab the instructions or data located in that address. The way it does this is through the data bus. Then, once the MDR has the instructions, it gives it to the IR, which keeps it, allowing for the CU to decode it. Okay, so now that the CPU has the instructions, the CPU needs to understand what the instructions mean. That's the decode cycle. The CU is the main part of the decoding cycle. It looks inside the IR, which has the instructions, and tries to figure out what to do with it. Let's pretend the instruction is addition. The CU will figure this out and tell the ALU to go ahead and perform some arithmetic. That's the execution cycle. The execution cycle is the ALU actually doing the addition and following the instruction. Once it figures it out, the result goes to the ACC or accumulator where it can then be accessed. And then the process repeats again with the next instruction, fetch, decode, and execute. Note, however, that the PC increments right after the fetch cycle. It does not wait for the decode and execute cycle to finish. In other words, right after the fetch cycle, the PC is already pointing to the next address of the next instruction.